Here we go. So we are live. So what we are going to do, as I was saying, is answer these questions. We had 6 questions. The first one is solve the separable equation. And the first equation is given as x times y squared plus 1 dx plus y dy equals 0. And the thing that most people forgot is y of 1 equals 2 given. So that's part of the problem. And so what we are going to do is stop the screen sharing, and you guys will be seeing the page on which we work. All right, so what do we do here? The first thing is separate the variables. Right here, I got y squared plus 1 nested within the x's. So I'm going to divide by y squared plus 1, and there's nothing else. So this is going to be x dx plus y dy over, I guess this is a modified problem, no? Is this the one you guys answered? Because I think I have modified this for another student that showed up later to take the test. Yes, it was the modified version.
The y is supposed to just be a regular y. Just
Yeah,
like y to the first.
yeah, that's I think that's what I'm undoing all the things that I changed on it to have his version late. Because we had a few small issues, so I had to figure a way to handle that. Just give me a few seconds, please. The missing students are still not here, actually. Okay, so yep, that's y, not the y squared here. And so what we do is we say that's over y plus 1 equals 0. And so you separate the variables, so the x dx equals negative y dy over y plus 1. Oh, thank God, just at the time we start, it shows up. Now, we integrate both sides. So that'll be integral of x dx equals negative integral of y dy over y plus 1. Now, what we do for this integral is to do that. This is y plus 1 minus 1 over y plus 1 dy, which is negative integral of 1 minus 1 over y plus 1 dy. This is called partial fractions and integration. This first integral gives you 1/2 x squared plus a constant equals the other one gives you minus y plus natural log of absolute value of y plus 1. That's it. And now initial values, you are going to say y of 1 is 2, so 1/2 1 squared plus c equal minus 2 plus natural log of absolute value of 2 plus 1. So c is equal to minus 1/2 minus 2 plus natural log of 3, which is minus 5/2 plus natural log of 3. That's it. And you bring that after finding it, bring it into the equation, because what you're looking for is the equation, not c. So that's 1/2 c x squared minus 5/2 plus natural log of 3 equals negative y plus natural log absolute value of y plus 1. That's it. So that's the final answer to the problem. And the second guy was simpler. And it stated that x squared plus 1 dy equals y dx. I think that's what it was. Again, it's a separable equation. So what you do is you separate the variables. X squared plus 1 we divide, y we divide. So we get dy over y equals dx over x squared plus 1. And this is the place where I ask to please review some of the things if you have forgotten, please. Because you need derivatives, integrals, the rules of derivatives and the rules of integrals. If you forgot them, please take time to review. If it's hard, you can schedule a meeting with me to discuss some of the things, because it's difficult when you miss a problem because of the integrals, right? But I don't teach you here how to integrate. So I try to limit the credit that I put on that. But if the problem is mostly that integral, then it's going to be hard to give you a lot of credit if you didn't integrate. So please work on that if you have issues. And so here, the next step after separating the variables is to integrate. So integral of dy over y is integral of dx over x squared plus 1. The integral of dy over y is natural log of absolute value of c times y. I put the constant with it. And the integral of dx over x squared plus 1, this is arctangent of x. That's it. You don't need to do anything else on this question. Now, the question number 2 was homogeneous equation. Solve the homogeneous equation. And the equation was given as x squared plus y squared dx minus 2x squared dy equals 0. Y of 1 equals 0. So homogeneous equation with initial values. Again, we start, get x squared plus y squared. When you start the homogeneous equation, the first step is you do y equals ux and dy equals u dx plus x du. That's the first step. And then you substitute that in the equation. And this is going to be x squared plus x squared u squared dx for y squared minus 2x squared, and dy is u dx plus x du equals 0. And the next step is regroup the things with dx. So that's x squared minus plus x squared u squared minus dx is here. So that is minus 2x squared u minus 2x squared u times dx minus 2x cubed du equals 0. And the lecture says that when you get to this step, what you get is a separable equation. So you need to separate the variables. Get the x's on one side, get the y's on the u on the other side. And here you can see you have x squared as a common factor. So you can divide the whole thing by x squared. When you do so, what you get is 1 minus 2u plus u squared dx equals 2x du. Because you divide by x squared the whole thing. And therefore now you can separate the variables. You get dx over x equals 2 du over u squared minus 2u plus 1. But thank God this thing is 2 du over u minus 1 squared. So when we want to integrate, we integrate both sides, put the integrals on both sides. The integral of the left gives you natural log of absolute value of c times x. And when you integrate the right, that's minus 2 over u minus 1, because the integral of du over u minus 1 squared is minus 1 over u minus 1. And now in the last step, what you do is bring back u equals y over x. And that's what most of the mistakes were, forgetting to bring back that u. And so here you would have ln of absolute value of cx equals minus 2 over y over x minus 1. And at this point, my advice is, if you're not sure of the algebra you're doing, don't do anything. Because some of you get this, and then now trying to simplify this, you bring the wrong calculus, you bring the wrong algebra in, and then I'm forced to take a point off because you can write the wrong answer and get full credit to the question. So here, if you want to do the algebra, you know that that's y over x minus 1. So you got to multiply and get the common denominator. That will be y minus x here. And x will go to the top. So that will be minus 2x over y minus x. And you can write this in circle, or you can keep it like that. You can multiply if you want, but it's now really not needed. So the final answer would be y minus x, ln of absolute value of cx equal minus 2x. That's it. Now, you want to use the initial values that was given. Y of 1 equal 0. So when when x is 1, y is 0. And that's going to be 0 minus 1 times ln of 1 of absolute value of c equals, and that side x is 0, so that's 0. So that gives you that ln of c is 0. What is c?
One.
That's it in this case. So c is 1. So you just replace that by 1 here, and then you get y minus x ln of absolute value of x equal minus 2x. Any questions? Is there any question on this part? If not, we move to the third guy. The third question was an exact equation, I think. Solve the following exact. And if you're having an issue with something, please tell me directly. Because if you don't, I won't know until you do it wrong when it's already late. Okay, and I did emphasize on the fact that you're not asked to show that the equation is exact, you're asked to solve, and it says it is exact. So just solve it. So the way we do is we go in front of dx, we have m. And in front of dy, we have n. And in the first step, we say derivative of f with respect to x is m. And that is x squared plus y plus 1. Derivative of f with respect to y is n. And that is, in this case, x plus y. That's it. And you start solving your problem. So f of xy is the integral of m, x squared plus y plus 1 dx. And that's integral, not derivative. So you integrate x squared, integral of x squared dx, that's 1/3 of x cubed. Man, I was seeing 1 cube, like 2 squares then. So 1/3 of x cubed plus integral of y dx. Y is a constant, so that is yx. Integral of 1 dx, that's x, plus h of y, because you took the integral with respect to x. And the next step says, take that derivative of what you just found, derivative with respect to y of what you just found. Derivative of 1/3 x cubed is 0. Derivative of yx with respect to y is x. Derivative of x with respect to y is 0. The derivative of y is h prime of y. And then the next thing is put that equal to n. So you got x plus h prime of y. That's derivative of f with respect to y. And the problem says that that is n, and n is x plus y. So you solve for h prime of y to find h prime of y equals x plus y minus the x that went to the other side equals y. Next step says you find h of y as integral of h prime of y dy. And that's, in this case, integral of y dy. And that's 1/2 y squared. You can add the constant where you don't need it if you know how you're going to write the final answer. And the next step says take that h into the formula of f. So f of xy equals 1/3 x cubed plus yx plus x plus 1/2 y squared. And you're gonna last step for the solution, set this equal to c, 1/3 x cubed plus xy, which is yx, plus 1/2 y squared equals a constant. That's the final answer. Any questions? Okay. The next one was solve first order linear ODE in two parts. The first one was y prime plus 3y equals e to the 2x, y of 0 equal 1. First step in there, find the integrating factor. Mu of x is e to the integral of p of x dx. Show work. P of x is 3 here. That's p of x. So that's e to the 3x. Next thing, multiply the equation by that integrating factor. So that's y prime e to the 3x plus 3 e to the 3xy equals e to the 5x, because e to the 3x times e to the 2x is e to the 5x. Next step, combine the terms on the left in one derivative. That's d over dx of y e to the 3x equals e to the 5x. From there, next step, integrate. You miss this step, there's no way you can gonna get that integral. When you integrate the left, you just get rid of the derivative, you get y e to the 3x equals, you integrate the right, you get 1/5 e to the 5x plus a constant, and never forget the constant of integration. The next step is initial values. Get y of 0 equal 1. So you get 1 times e to the 0 equals 1/5 e to the 0 plus c. E to the 0 is 1. So you got c equals 4/5. That's it. You plug that in there. You got y equals 1/5 e to the 3x, e to the 2x, because you divide e to the 5x by e to the 3x, you get e to the 2x plus 4/5, and then 1 over e to the 3x is e to the minus 3x. That's your final answer to the problem.
Okay, I have a question.
Yep.
Okay, every single time on this type of equation, I always get mixed up on the when I combine after you get the integrating factor.
Mhm.
The part where you have d over dx next to that ye3x. I just don't understand how to get to that point. Like I mess it up on every problem like that.
I know we got to that, and the issue is when you're finding the integrating factor, it's something that you need to understand here, which is the reason why you're finding the integrating factor is that actually you want that left-hand side after multiplying to be the product rule. This here is the product rule for this, which is f prime g plus g prime f, which stands for the derivative of f times g. So it's written in this form, and we combine it to write that in that form. Here, f is y, and g is e to the 3x. So you got y prime times the function plus derivative of this one g prime times f, which is f times g, y times e to the 3x, derivative d over dx. So it's the goal of the integrating factor to be able to combine like that. And anytime you find that integrating factor, you need to know that your left-hand side is always going to turn into d over dx of mu of x, y, no matter what is the problem you're solving.
Okay, now I understand.
Does that make sense?
Yeah, it makes complete sense.
Mm. So this is the thing. So once you get that, you always know, okay, I'm going to multiply, but I know eventually this is where I'm going to end, right? Any other questions? And it's important to understand this because it comes back in the next topic, right? Because Bernoulli equations, you do one step and it takes you back to the linear problem. So if you can solve the linear, you can solve Bernoulli. Any other question? We all good? Okay. If you say so. Now, so for this next problem, again, we start by finding the integrating factor. In this case, it's, again, mu of x e to the integral of p of x dx. That's it. And then in this case, p of x is 1 over x. So that's e to the integral of dx over x. That's e to the integral is ln of x. E to the ln of x is x. Oh, beautiful. So our integrating factor is x. We go to the next line and we multiply the whole equation by x. So we get x dy over dx plus y equals x to the 6. So we multiply throughout. And now, as we were saying in the previous one, look here, the derivative of mu, the derivative of this x is 1. So this is the product rule for x times y. So combining, that's d over dx. On that left, x times y. And like I was saying, mu, that's x. That's what is going always to be there. Equals x to the power 6. And then you go to your next step where you integrate. And when you integrate, always you get rid of that d over dx. After taking the integral, you get xy equals integral of x to the 6 dx, which is 17x to the 7th plus c. Again, most of the time we forget about this constant of integration. And then we get y equals 1/7 x to the 6th plus c over x. Notice that in this case, when you forget the constant of integration, it's not just a constant you're missing. You're missing c over x. That's a bunch of functions, right? It's not just c. Questions? This one seems easier, right? Now, next question. It was just show. Do last. This, I think, was the easiest questions on the test. Is the equation exact? And the equation was x plus y dx minus y minus x dy equals 0. So this is the problem, and we want to know if it is exact or not. So what we do is we go there and we get m in front of dx and n, everything in front of dy. And so we get dm over dy That's derivative with respect to y of x plus y. That's 1. And then we get dn over dx. And that's derivative with respect to x of minus y plus x when you distribute that minus sign, and that is 1. And we can see that these two things are equal, and that implies that the equation is exact. That's it. That's all. Nothing else to do. No solve. All the question has to do was, is it exact? Yes, we have established that it is exact. That's it. And the last one was, is the equation homogeneous? And the equation was x minus 2y dx plus x squared dy equals 0. And the way we did this was we defined the functions m and n that are here. We find out if each of these functions is homogeneous and if they have the same degree of homogeneity. That's how you conclude that it is, the equation is homogeneous. Otherwise, you conclude no. So you would say m xt yt is, this is xt minus 2yt, and that is t times x minus 2y, which is t times m of xy, because this is m of xy. So this has degree 1. N of xt yt is xt squared, which is t squared x squared, which is t squared n of xy. So here, that's t squared, so the degree is 2. Different degrees implies that the equation is not homogeneous. That's it. And here we say the end of the test. Questions?
So the degree couldn't be 1/2. I mean, could you explain that, please?
The degree is the power of t that pops out of each of them. Out of the first one, it's 1. Out of the second, it is 2. And for the equation to be homogeneous, you need to have the same degree for the two functions. You don't have the same, the equation is not homogeneous.
Okay, thank you.
You're welcome, sir. So and it's good to have that clarified, because it can play in other things, not just this course. For those who will take other courses that are related to that. Any other questions? If there is no other question, then we are going to do what we call Bernoulli equations. How I love them. And that will be 2.6 if you want the section. I'm change this. Make sure we understand it's not more the test. This is the new material. New material. Section 2.6, Bernoulli equations. So if you understand well the linear equations with me, this one is going to be just like a game, because after the first step, you just have to repeat everything that I showed you before. The difference between Bernoulli equations and the linear equations is that a Bernoulli equation is just a linear equation that you took and you multiply the right-hand side by the power of the function. That's it. And I say so, and the lecture is over. It's finished, right? So we say an equation of the form dy over dx plus p of x y equals f of x y to the power n is called Bernoulli equation. Notice that if I cover this y to the power n, that's exactly what we called first order linear equation. All they did is to take that first order linear equation, multiply the right hand side by y to the power n, and you got Bernoulli. And if you understand that, then you also understand how we solve it, because we solve it by undoing that multiplication that they did. You divide the whole equation by y to the power n, and then we do a substitution. And after that substitution, everything else is a linear. Okay? That's it. So, how do we solve this? Step 0. Before you even start thinking, divide the equation by y to the power n. So you divide the whole equation by y to the power n. When you do so, what you obtain is y to the minus n dy over dx plus p of x y to the power 1 minus n equals f of x. That's what you will always obtain when you do so. Divide by y to the power n. Now, in step 1, we say, please raise your head, look carefully at this board. What's going to happen there? Magic right here. The magic starts. Hey, this thing is the new function. You remember in the linear problem? In the linear problem, what was here multiplied by p of x was the function that you're looking for. So you make this new guy the new function that you're looking for. So we said w equals y to the power 1 minus n. Get that coefficient of p of x, make it the new function. So instead of solving for y, I'm solving for w. I want w, not y. Now that I want w and I know y is a function of w, I also have to find the derivative of w, because what I have in the equation is the derivative of y. So I got to make sure I bring back the derivative of w. So I'm going to find the derivative of w and make it look like something that has this so that I can replace it as well. And then get rid of the y's, not have any y in that equation anymore. So this is w. If I apply the chain rule to find the derivative here, dw over dx Chain rule, chain rule, chain rule. It's not something you just memorize because I wrote it down. It's the chain rule. Derivative, you remember chain rule? Power rule first. 1 minus n goes down, right? When you take derivative of a power, 1 minus n goes down. That's 1 minus n. Y to the power, 1 minus n minus 1, right? Everybody agrees with the power rule for derivatives, right? So now that's y to the power 1 minus n minus 1 times chain rule, because derivative, you're taking derivative with respect to x, and y is a function of x. That's why you have dy over dx. So we do power rule and chain rule to get this derivative. And it's always going to be that. Now you can see 1 minus n minus 1 is just minus n. So this thing here is nothing but 1 minus n y to the minus n dy over dx. And look at this beauty at the end here. Check this thing. This thing I'm circling here. What is it? See that here? You see that? What I just circled here is exactly what you have here in the equation. And we are just going to replace that thing in the equation. And what is this equal to? It's 1 over n minus 1 dw over dx. So we can replace this, solve for this. 1 over n minus 1 dw over dx is y to the negative n dy over dx. This thing, we solve for it here from this equality, this and that. So we replace that in the equation as well. So the equation becomes 1 over n minus 1 dw over dx. That is this piece. I just showed you it is this. So I replace plus p of x, and then this is w. That's w. We decided to make it w equals f of x. And guess what? You can recognize here that this is a first order linear ODE in W, right? Do you agree with that? So if you really master that linear thing, all you need to do here is just remember how to do this transformation. Once your transformation is done, the rest is like easy. You know how to do it already.
Professor Longwell?
Yes, sir.
In the bottom equation at the far left, should that be 1 over 1 minus n?
Oh, yeah, it's 1 minus n, sorry. Thank you. I was so happy that I turned it around, because you do that, this one is going to be wrong. If we do n minus 1, it's 1 minus n. Thank you. And both here and here, because I'm just solving this, right? I'm just solving the equation that is there. And so we get the first order linear ODE, and then we just continue. And I'll continue putting the steps here to solve the first order linear equation, because anyways, we say teaching is about repeating. We repeat, we repeat, we repeat in the hope that we finally memorize, right? So here, what we do to solve the first order linear equation, we make sure we have it in the standard form. So we make sure that the coefficient of the derivative is 1. That was the first thing we did, right? So we do the same thing here. So here, we are going to make this first thing 1. And so the 1 minus n is going to go over here times p of x w equals 1 minus n f of x. Notice that I'm doing this and I'm solving without even knowing what is f of x, what is p of x, right? So the method works no matter what you have as equation. It's always going to be the same thing. Why not just put all of them down like that and just follow them when you need, right? It's gonna be the same, exactly those same steps, no matter what is F, what is P, what is N. You're gonna just do that W, do that dW over dx, get that equation, so get this equation. It's gonna be the same thing. Now here, in the steps of solving the linear, first order linear, what you do here is find, this is standard, right? Standard form. You find the standard form, and next you find mu of x, which you call the integrating factor, e to the integral of, in this case, this is the function that you use. So that's 1 minus n p of x dx. You find that. Then multiply. When you multiply the whole equation by that, mu of x dw over dx plus mu of x 1 minus n p of x w equals mu of x f of x, right? And then after multiplying, what do we do for the linear problems? What's the step after multiplying? We discussed that today again when we were giving the solutions of the test. What do we do after multiplying by the integrating factor?
You
Well,
can change it to d dx of
yeah,
the 1 minus n p or u of x p
you,
of x.
you, right. Thank you. So you when you do this, you combine now these. That's what she's saying. You combine these two into one, right? To get d over dx of that. So combine. So the step will not change. So that's d over dx of mu of x w equals mu of x f of x. And what's the next step after that?
Integrate.
Integrate. You guys know it. So it's just gonna flow. So integrate both sides. And so you're gonna get mu of x w equals integral of mu of x f of x, and then divide. Get w equal, and then in this case, one last step that you need here that you didn't have there is return to w equals y to the power 1 minus n, because that's always important, because you were solving the problem in terms of y, not in terms of w. So after finding w, you return to w equal 1, y to the power 1 minus n, and you have your answer. That's it. And after that, you look at this and you just say, hey man, this is just all new topic, right? So any questions on these steps before we apply it to a concrete problem?
Where did the 1 minus n go that was on the side with the function of x in the equations? Like it's there on step 3, but it's not there the rest.
It's there. That's just me following. Technically, I'm telling you, you don't need to memorize these equations after this. What is important is the words that go here, what you're doing, right? And you can see that I'm even writing that down. I could forget to put that down there. But if you're doing it on the equation that you have, you're just using the previous line to go to the next. So you don't have to memorize those formulas going down. Thanks. Anything else? Okay, let us try to do this on the first problem here from your textbook. see how it works. dy over dx, example 1. dy over dx plus 1 over xy equals, it looks like a problem we had today. We just multiply the right hand side by y squared, right? Our problem was equal x to the power 5. And you just multiply by y squared. Okay, so you got the steps. I'm gonna write them down. Step 1, no, step 0. Divide the whole thing by y squared. So we go y to the negative 2 dy over dx plus 1 over x times 1 over y equals x. In step 1, I said this thing, you set it equal to the new function. So w equals 1 over y. Do you see why I was saying it's not necessary to memorize formulas? You don't see me here writing the 1 minus and those things, right? Because I'm just reading what I have here. So I read 1 over y, that's 1 over y, that's w. And then you take dw over dx. You don't need to memorize anything. You take the derivative of this. What's the derivative of 1 over y? That's minus y, 1 over y squared. That's a derivative if it was just 1 over y, the function, the variable. But then it's chain rule because y is a function of x. So that's why it's times dy over dx. That's it. And you get the same formula you will get if you memorize it. So derivative of 1 over y, it's minus 1 over y squared. But because we are taking derivative with respect to x, we need to multiply by dy over dx for the chain rule. Then on step 2, step 2 says, take these two things, substitute back there. And to do so, you got to solve for 1 over y squared dy over dx. This derivatives means that that one is negative dw over dx, right? To get this, I just need to multiply by minus 1. And so 1 over y squared dy over dx, that's this, y to minus 2 dy over dx. So my equation here is going to be negative dw over dx plus 1 over xw equals x. That's it. That's the new equation. And then I'll have to bring it to the standard form, making sure the coefficient in front of w is 1. In this problem, I do that by multiplying the whole equation by minus 1 to standardize it. And when I do so, I get dw over dx minus 1 over xw equal minus x. That's the equation that I have to solve, and that is first order linear. This is a first order linear problem. That's a first order linear ODE. So to solve it, we need to find the integrating factor. U of x, again, just read it here. You don't need to memorize anything. What's the integrating factor? It's e to the integral of p of x. What is p of x? The coefficient of the function. What's the coefficient of the function here? That's it, right? So that's e to the integral of p of x dx. That's e to the integral of negative 1 over x dx, which is e to negative natural log of x. And in our first lecture, I was discussing this. You need to make sure when there is a negative sign here, you bring it inside. So that's e to the ln of x to minus 1, because negative ln of x is ln of x to the minus 1. And e to the natural log of that is just x to the power minus 1, which is nothing but 1 over x, not minus x. The common mistake usually is that people turn this into minus x, but that's not right. You need to take the minus inside. It goes in as a power. Natural log and exponential cancel. You get x to minus 1, which is 1 over x. Am I making sense with this? All right. So from here, the next thing is, yes, Cooper?
I was gonna say something, but I just answered my own question.
All right. And so here we are going to multiply the whole equation by the integrating factor, which is 1 over x. And therefore, we're going to get 1 over x. So here is multiply. You get 1 over x dw over dx minus 1 over x, and then 1 over x, that's 1 over x squared w, equals, you multiply the right-hand side by 1 over x, you get minus 1. And again, as in the previous one, we combine the left. Combining terms on the left, that's always going to be d over dx, the integrating factor, 1 over x times the function w, equals negative 1. And the next step is integrate. When you integrate the derivative, you get 1 over x w equals integral of negative 1 dx, which is minus x plus a constant. And then you multiply here to get w equals minus x squared plus cx. And then you remember that w is 1 over y. So y is 1 over w, which is 1 over minus x squared plus cx. That's it. Questions? So here it's like straight by the bullet points of the lecture, right? Now let me keep this answer here and give you an example to solve. We have x, example 2, x dy over dx plus y equals 1 over y squared. So let's go. Take 5 minutes, think a little bit, and try to follow exactly these steps. So anyone wants to try? I'm not gonna kill anyone for the wrong answer.
The first thing I did was I divided everything by x.
That's not exactly following exactly these things. You will understand why if you follow exactly that. Starting by dividing by x is adding work for nothing, no reason. Because anyways, you are going to have that step later on. That step is right here, standardize.
I divided everything by y to the -2.
By y to -2, yes. So that's the first step. Always in the first step, make sure you get rid of the powers of y that are on the right. You start by something else, you're just going to add more work to what you need to do. Because everything actually is taken care of in between. The dividing by x that you suggested, it's not the wrong thing to do, but it just adds work, okay? Because you do that here in step 2. Does that make sense?
Yeah, that makes sense.
Mm-hmm. So it's not wrong. Just start right away by multiplying, dividing by y squared, as he said. So we are going to have in our step 0 x y squared dy over dx plus y cubed equals 1. That's what happens when you do that. What's the next step after that? Right.
You solve for dw over dx.
Yeah.
Before that, what do? You jump in one step.
W equals y cubed.
Yeah, w equals y cubed. So you just need to copy these things, man. Just copy them down, and it will just follow, right? So w is y cubed, and now you take derivative, man. See what you get as derivative.
3y squared.
3y squared, and then chain
dy.
rule, dy over dx. Chain rule, always don't forget. Okay, and when you do that, you can see here, as we did before. So that's y squared dy over dx. That's it right here. Y squared dy over dx. So you solve for that. You get y squared dy over dx is 1/3 dw over dx. That's it, right? And so this thing, you are going to substitute in that equation. And so that's what gives you your next step 2. So that is 1/3. And then the x that was there, x, then 1/3 dw over dx plus, and that's w equals 1. That's it. And now comes the step that we wanted to do earlier, standardize. Which means make sure the coefficient of dw over dx is 1. How do we do that here? We multiply by 3 and divide by x right away. So it's going to be dw over dx plus 3 over x w equals 3 over x. That's it in one step. Does that make sense? And now you recognize that this thing is first order linear. In W. So that's first order linear in W. So we find the integrating factor, mu of x, and you just read the equation. So that's e to the integral of p of x is what is in front of w. That's 3 over x dx. That's e to the 3 natural log of x. And that's e to the, again, that case, 3 comes inside. It becomes ln of x cubed. And e to the ln of x cubed is x cubed. So mu is x cubed. So we multiply the whole equation that we got here by x cubed. So it becomes x cubed dw over dx plus 3x squared w equals 3x squared. You see how beautifully it comes out? Now here we combine, right? When you combine, you can see that 3x squared, that's the derivative of x cubed, right? You can see that. So this tells you clearly, okay, this is the product rule. D over dx of x cubed w equals 3x squared. And then your next step is, example, this is 6, integrate. So you get x cubed w. Integral of 3x squared is x cubed plus a constant. And then you have to return w. So w is, in this case, y cubed. So you get x cubed y cubed equals x cubed plus a constant. You can keep it like that, actually. Right. That's it. Final answer. Any questions?
Will there ever be a time where we have to put the y by itself, or we can always just plug in what we have for what w equals, and then that'd be the last step?
Yeah, you can keep it like that or continue solving. I really don't make a big deal out of that. Because it really changes absolutely nothing. It's as long as you bring back the w, right? As y to the 1 minus n. Okay, so is time over? Yeah, I think I might be off by already 4 minutes, right? So I think we stop here. If you guys have any questions, please let me know. If you don't have any questions, we can stop here.
Thank you.
Thank you for coming today.
Thank you.
Great day.
Thank you.
Bye. See you next time.